So ammonia is the second most, you may have already spoken about this in the past, but ammonia is the second most produced chemical in the world. It's a critical raw material, feeds 7 of the 8 billion people in the world, 80% of which is used for fertilizer, 20% for a bunch of other industrial uses. But this critical raw material consumes 2 to 3% of global carbon emissions, and perhaps more immediately, we produce it in giant centralized plants, which your BASF spoke about earlier. We produce it in these giant centralized plants and then ship it all over the world. The average bag of fertilizer travels 10,000 kilometers to get to farmers in our first market, which is sub-Saharan Africa. So I'm going to cover three things pretty quickly: why ammonia, why modular, and what we're doing at Talus today. The origin of Talus was actually philanthropic. We have funded this effort for the last 10 years to build a low-cost modular green ammonia system to locally produce basic fertilizers for farmers in sub-Saharan Africa. And we've done that. We deployed the world's first modular green ammonia system, put into actual commercial service last summer. It is 20 to 40, that system produces fertilizer that's 20 to 40% cheaper than imported fertilizers. It guarantees availability and reliability, and our system is of course carbon free. But when we think about why modular and why decentralized, for something like ammonia and fertilizers, which is a cheap bulk product, 50%, half of the cost of a fertilizer is effectively distribution. So if you can locally produce it without having too much of the problems of diseconomies of scale, you can have a product that is cheaper, that is more affordable, that is more reliable, and that is more sustainable. Why modular? Our systems are rapidly deployable. It takes us under 1 month to install and commission a system, 2 to 3 months to manufacture, 1 to 2 months to ship on site. They're built into standard size shipping containers, and they're shipped and trucked onto a site in a crane, effectively places them onto concrete piers, and in under a month we can be producing ammonia. So they're rapidly deployable. They're rapidly upgradable. You know, as some of the guys before me spoke about, there's really interesting advancements coming on with hydrogen technologies, with ammonia synthesis technologies. While we have our own proprietary ammonia synthesis technology, fundamentally, if someone comes up with something better, we can swap to that and lower the cost. Our goal is to lower the cost of basic fertilizers for the farmers we serve. What's really changed for us recently has been we originally focused on farms in sub-Saharan Africa because their cost of fertilizer was so high, because delivering anything into those markets was really expensive. What's changed is our costs have come down to a point where we are competitive for large commercial farms in sub-Saharan Africa. So we are deploying another 5 systems in sub-Saharan Africa to some of the largest farms in the world there. The other 2 markets that we are now starting to serve are mining. One of the other large use cases for ammonia is upgrading to ammonium nitrate, which is used as a blasting material. We're working with BHP and 2 of the other global mining majors to deliver our systems onto their mining sites. So it's really the same idea. If you can decentralize production, especially in these remote locations where delivering blasting material is expensive, it's unreliable, and it's unsafe, right? We've had a lot of accidents. In the US, we have rails accidents. In the rest of the world, a lot of trucking accidents when transporting these dangerous materials. If you can locally produce it and control it, it can be cheaper, it can be more reliable, it can be safer, and in our case, carbon-free. When we think about decarbonization, for crops, using a carbon-free fertilizer will reduce the CI score of a crop by 30%. And for mining, it will reduce the scope 2 emissions for copper by 6 to 8%. The last thing I'll talk about is where the last market that we're focused on now is the United States. Supported by the Inflation Reduction Act, we can make the exact same arguments we make to an African farm. We can make those exact same arguments to a US farm. And so as a result of that, we have around $1.5 billion of offtake agreements now. We are deploying we've scaled our manufacturing now to be able to deploy around $300 to $400 million of systems per year, starting around end of year. next 4 systems are delivering now, or next 5 systems are delivering now. But around year end, we scaled our manufacturing, but we're scaling our deployment and installation teams so that we can install 2 to 3 systems per month starting around year end.